I think Caleb's exactly right. Under a B theory, it doesn't make sense to say that, well, something just doesn't. Like, for instance, and this is what I did with, let's grant that you plan on having children. They exist in the future, but not now. So under his view, he would say they don't exist because the future doesn't exist. Under my view, they do exist, just at a different point in time. You're not there to be experiencing it, but that doesn't mean the point doesn't exist. And I do this frequently to draw an analogy because at least I think it helps. Imagine the Eiffel Tower, if you will. None of us, I presume.
Well, I don't have to imagine it because I was just
none of us
an Eiffel Tower a couple of days ago. The Eiffel Tower in Vegas.
Yeah, right. None of us, I presume, are near the Eiffel Tower, and I'm talking about like the actual one in Paris. But none of us would say, "Oh well, I can't see it or touch it or taste it because of where I'm at in space. Therefore, it doesn't exist." Nobody would say that. It'd be absurd. Of course, it exists. You're just not in Paris. That's the thing. It's the same. That's space. That's being disconnected in space. The same thing with time. Just because you're disconnected from an event in time doesn't mean it doesn't exist. You're just not there in the same moments of time to be experiencing it. Much the same way with space. You're not near the Eiffel Tower to be experiencing it in space, but it's still there. It still exists. And we need to look at, I would say we should look at time the same way.
It's interesting. You described the word time when I asked you to define it. You defined it as a dimension akin to space. Why do you define it that way? Because I am familiar with that definition, but why do you think that is the one that ought to be considered time in colloquial usage?
Primarily because when we understand things in a relativistic framework, even when we're doing things like relativistic quantum field theory, there are something called, you generally see just in classical special relativity, something called a Minkowski space. And what it does is, instead of dealing with a three-dimensional, coordinate space, you're dealing with a four-dimensional coordinate space, except that other dimension is time. It's a little different in the sense that and I'm using loose analogical language here to try to paint a picture. It wraps around the other.
Before you do it, Leo, this will answer Ada Lovejoy's question because she's literally asking the question, can you explain space-time? Okay. Yeah. So go ahead.
So time as a dimension wraps around the other three spatial dimensions. So all spatial dimensions, I guess, in a very analogical sense, you could consider space as three dimensions as nested inside of a higher dimension that we call time. Because regardless of length, you can measure length and time, width and time, height and time. So time is just another thing that we use to measure what the things in reality are doing, just like space. We use rulers to measure lengths. We use clocks to measure time.
The way that I use the word time is as a measurement of the rate of change of matter and energy. And I don't conceive of time as an actual thing that exists in and of itself. My view of time is a unit of measure. And I'm curious as to what you think about that, because I understand time in the way that I understand inches or yards or volume or weight. As in, they're not actual things. It's the measurement we are applying to something else. So how do you think about that?
So I would say that time is a real thing, primarily because even when we break reality down to its most fundamental constituents, you can't do good luck being able to derive an actual Lagrangian or Hamiltonian equation of motion without incorporating time.
Well, but you
can use time independent variations of these equations, but they don't apply in the most instances because time is a real thing.
You just said in that your measurement of motion, which is pretty much synonymous with my usage.
Well, but these aren't just measurements. There's a thing that has to be measured in order for you to take a measurement.
Right, but the thing that we're measuring
is time.
Are we?
Yes, in much the same way that you measure length. Like if I hold up this lighter, length is a property that is even if no humans ever existed, this object still has length. You might not be able to measure that property, but the property still exists. This lighter is extended through space, and we can measure its extent through space, much the same way objects are extended through time. We just don't use rulers to measure that. We use clocks.
But we're measuring movement and change.
That's the thing I want to focus on right there is change. Because honestly, I think that's the easiest, personally, to sort of interject my opinion here. I think that really to simplify this even further, is that time is measured change.
I would say change is measured using time and space. So if time is just a measure of change, then space is just a measure of change. But space is not just a measure of change. You can have something static in both space and time.
See, here's my thing, though. I agree that if you were to think about this in these terms, you need to think about space differently than you would time. And I grant that space and time are correlated, but I don't think that time, in the sense that here's my 2 cents. I think Bryce and I are leaning towards the same intuition here, that time isn't an actual thing. That I'm with Bryce on this, that I think that time is a measurement of a thing. And I think that what we're measuring ostensibly, to put it in simple terms, is our particular location within, quote, space time, relative to some other object. And that's what we're referring to. And to me, what we're really actually measuring is, what does space look like in this area versus this area? And the distance between those two is more space.
Frames of reference.
Yeah, it's just more space, but there's not time there. It's just more space between the two.
And maybe to give you a little bit more, Leo, to kind of break down, you described time and space as properties, and I would agree with you. Length is a property of an object, and time is a property of things in motion. But I don't think that something is I think that a property and a physical existent thing are two different things, because blue is also a property. But I don't think blue is something that exists either. I think blue is a description of wavelengths of light that's made of photons. The photons exist, and the rate of their movement can be tracked. But blue is a property that's really just a description. And I think length fits that definition as well as time. So
there are two things here. The first is a quick correction.
Okay.
So things can be static and still be in time. Remember, I'm standing still right now, but I'm still in time. Something does not have to move or be in motion to be in time, which is something
that's not correct, though, because it is.
Hold on, Caleb.
It is.
Let him finish.
From a theoretical physics standpoint, yes, it is correct. We can measure objects that have absolutely no motion in space-time, and their clock will still tick.
What is an example of that?
Per second. My lighter sitting on my desk is not in motion. Its clock still ticks at 1 second per second.
But it is in motion.
No, the lighter is not in motion.
Well, but the Earth is in motion.
The Earth is in motion, but the lighter, relative to the table, is not in motion.
Relative to the table, but relative to the moon, it is.
That was my point. Is that this is extremely
well? Then we
relative.
have to take. But then that just comes down to space-time diagrams. But
in order
if you take a space-time diagram where there's nothing moving, it still moves.
Hold on, one at a time. Repeat it, Leo.
So if you take a space-time diagram where something is not in motion, which is the best that we can do, it still moves in time. Its clock still ticks at 1 second per second.
Okay, go ahead, Caleb.
All right, my point is simply this: if we can imagine that there's some local area, we'll just imagine this spot here for the sake of argument, where there is absolutely zero change, all right, void of all reference. I don't think you could say that an area with zero change has time in it. What you seem to be suggesting is that, well, we can look at something that doesn't seem to be changing. but looking at something means that you are existing in an environment with, these might not look like it, but with positive integers of change. There is change occurring in your environment, but not this local area. This is an instance, even if this change surrounds the area where there is no change, there's still an instance in the set of change occurring. So of course time exists in this scenario, but in a scenario where there is no change occurring at all.
Can I ask you, Caleb,
if there is no observers, if there are no observers, excuse me.
Can I ask you, Caleb, if this simplifies it? I'm not sure if this is where you're going with it, but this might be a simpler way of looking. You just drew a circle and an X on that diagram. Am I correct?
Well, it's hard to see, but I essentially I'm just trying to imagine a pocket where.
What did you draw?
An area, a circle,
okay.
where no change occurs, and we can imagine everything outside of that circle. There is change occurring.
You drew an X outside of the circle?
Several, yeah.
Okay,
supposed to be plus signs.
You have a circle and plus signs relative to each other. They are not changing, but if we, well, they're still in the same.
The plus signs are my example of change. That's what I'm saying.
I know that's what you're doing, but I'm trying to use what you draw as a different as a way to maybe illustrate another question. I suppose. So you just drew a circle and you have pluses around it. They are static relative to each other. Like literally, I'm not talking about in the hypothetical scenario, but literally those marks have not moved. They are the same distance from each other. They can't move. They are static, right? If we take the paper that you drew and started spinning it around, it is in motion from our perspective, but the X's and the O's are still static from their own perspective relative to each other. Now, with that in mind, Leo, doesn't that mean, and the answer to this question is obvious, of course, time is relative, but due to the relativity of time, doesn't that mean that everything is actually in motion? It just may appear to be not in motion from the perspective of something near it?
In some sense, yes.
Okay, so because that's what my question was. You described a scenario in which space and time become literal things because if something was static, then you continued on with that thought. But I guess my point is, I don't know that there's any such thing as something being static, because even if something appears to not be moving, but it's still moving relative to from the perspective of someone else.
Absolute changelessness isn't something that could ever be conceived of, or I should say not conceived of, but realized in reality due to Heisenberg's uncertainty principle. But I can still have a space-time manifold with absolutely nothing in the manifold. Just because there's nothing in the manifold does not mean the manifold isn't there. You wouldn't be able to measure anything in the manifold because there's nothing in the manifold. But to say that, well, if I don't have anything in my coordinate space, then I don't have my coordinate space is from both a mathematics and a physics perspective is just not true. We can conceive of space-times that have no objects in them, but there's still a space-time there. Whether those actually exist or not is a different story.
I was going to say, isn't it purely conceptual then that way?
Not necessarily. It doesn't violate any of the laws of physics we know. To the point we were talking about earlier, Icarus brings it up. His comment says, quote, and it's from the Stanford Encyclopedia of Philosophy article on time. He says, quote, McTaggart concludes that since neither the A series nor the B series can order the time series, time is unreal, end quote. And one of the reasons why most theoretical physicists would not accept the notion that if there were no objects extended through space-time, that either time or space or both space-time would cease to exist. The reason why they don't accept that is the fact that things inside of space-time can affect both space and time. If those weren't a real thing, then why do real things affect it? If it's just a concept that emerges of our abstract measurements, then why do physical things affect it? There has to be something actually there independent of our existence or our observation. And this is why most theoretical physicists would say space-time is a real physical fundamental manifold which exists independently of us or any measurements made on it. So, I had a friend of mine who's a PhD astrophysicist. I asked him, John Kroon, I asked him, if he thought, I said, in your view, do you think that time is real, or do you take this view that if you weren't measuring it, it wouldn't, if you couldn't measure time, or if there was no change, that time wouldn't exist? And he said, I mean, if I couldn't measure the mass of an electron, would mass stop existing? Is mass real? Is mass a real property that things have? Because he said the thing is, time is treated like a property intrinsic to objects in quantum mechanics, which it is. It's a complementary property with the energy contained within an object.
I get that,
which we should not expect. We should not expect that. Just like we can measure position, which would be position in space. When we talk about measuring time, what we're talking about is essentially measuring position in time. So position in space is where something is located in the X, Y, and Z dimensions. Time is really just position in time, or where something is located in the T dimension. Something isn't changing. It still has an X, Y, Z, and T number, even if it's not moving, but not changing, because it has to exist in that manifold. So it has to have a T number.
That exists that's
it's just that the T number doesn't change. You would just have one T number, but it still has a number, and it's still a real number.
Leo, is this a false statement? There's nothing in existence that is not moving.
As far as we can tell, that is a true well, define motion. Motion relative to what? That is what most physicists would say. Motion relative to what?
Anything else.
Oh, what we're saying is that motion is not the same thing that time is.
Because I know that that's your argument.
Well, that's not my argument. That would be what the physics tells us.
But my point is, when you say that, hold on,
there are multiple schools of thought on this. You say that is, granted, there's probably very likely a major consensus on this, but
my problem with the way that it's being presented here is that every time time is defined as a thing, it necessarily seems to include the element of motion, or the apologetics for why it has to exist includes the explanation of things in motion. There's no demonstration of anything not in motion, which is why I'm defining it as a necessary component.
Well, but hold on. If we've never observed anything not in motion, then how could we say that it doesn't have time if it's not moving? We don't know that. We've never measured it.
It's not only that we haven't observed anything in motion, but the idea of things not in motion is inconceivable.
Exactly, which is another reason why I would say time is physical. The thought experiment of, well, but what if we consider something that literally absolutely undergoes absolutely no change? Well, such a state is not actually possible, so it wouldn't matter to physical reality.
I played a lot of devil's advocate here with you, Leo, just to have a more dynamic
and it is
discussion.
Great. It is. Yeah,
and I just I want to see if you can understand how, maybe from my perspective, the argument that you're making sounds a little bit like when a theist, to me, it sounds a little bit like when a theist says, if God wasn't real, then X, Y, and Z couldn't exist, but that's the thing that they're trying to prove. It almost sounds circular. It sounds like you're saying, I define time this way because if I don't, then the conclusion I'm trying to get to wouldn't be my conclusion. And so it kind of sounds like a tautology to me, in the same way that a lot of theistic arguments do. You're probably right. You know more about this than I do. I'm a skeptic. And because I lack the knowledge and information, it's more difficult for me to accept your explanation of time, just based on the fact that I have no knowledge of anything that's not moving, and it seems that everything that's ever been observed is moving. That's an argument of intuition. Intuition is often wrong, so my argument may be wrong, but I would need more to be convinced that we, other than saying this is one way to define time that's useful for physics and mathematics, and here's another way to define time that's useful for a different conversation, I'm willing to do that. But if we say time is necessarily a thing that exists because my model of physics demands it, but we can't show any alternative, that's hard for me to digest. But does it make sense to you, like the way that the reason why I was
sure. Yeah, that makes sense. I just wouldn't call that circular reasoning. If we say, well, this model of time must be correct because physics demands it, and I would say physics does, but we can't observe it being different, well, it doesn't matter. This is what physics tells us. This is what we should go with. Our equations of motion cannot model non-physical, conceptual, abstract things. They're not present in any equation of motion you could find anywhere in physics, which is why I don't think that time is abstract. I don't think time is something that emerges from us measuring things changing in reality. I think time, and I think most physicists would say time seems to be, if we look at special relativity and general relativity, and then even things like quantum mechanics and how fundamental time is to everything in that, and that we can't actually map what reality is doing unless we incorporate this, that this is some physical property of reality that is different than other things that we experience. And I think that's one of the things that interests people, that draws people into these questions about time, because it is something that is different in terms of our experience and how we experience reality. I did want to say really quickly, Bryce, that your pushback is the kind of pushback that I wish theists knew how to give, because it's the pushback that makes you think about the things that you're advocating for, instead of just your ability to regurgitate, an answer to an objection that you've done a million times. And those are the objections that make people say, you know what, hold on, let me think about that. Though that's when you're asking the right questions. And
I'm not committed by faith or anything else to my conception of time. It just happens to be my conception, and it is subject to change with information.